Okay, I'll record on this computer. Okay, cool. I think we're good. All right, so hey everyone, I'm Niema Moshiri. I'm an assistant teaching professor in the computer science department. I'll be doing a Reddit AMA today. So thanks everyone who's joining live. And then this will also be recorded. So if you can't make it, you can just check it out afterwards. I have Reddit ready to go. So I'll just kind of be responding to questions that people left. And yeah, hopefully it's helpful. So I'll just first go through the Reddit list and just kind of go top down. So first question. Oh, not a question. No question. Just want to thank you for leading the online CC 100. Nice. Yeah, I'm glad to do it. Online learning is important, and I'm glad 100 went a lot better than I was expecting. So the question is, what is your opinion on Gabe Newell's statements about BCI research in the context of research going on in his own company, that the matrix is a lot closer than people think, that brain-computer interfacing will be an extinction-level event for every entertainment form that's not thinking about this? I don't know. I've actually never heard of that. I don't really know much about like brain-computer interfacing. Yeah, I think it's just like any other technology, right? If you have TVs coming out, all the entertainment media has had to figure out how do we get like story writing onto a TV. When TVs became, like cell phone sized, like I have a phone that is a TV, game developers had to think like, how do I make it mobile? So I think any big technology that changes how humans interface with technology, it's just another opportunity that I think any medium needs to think about. So let's see. So I think just like every big shift in technology that allows humans to interact with entertainment in some fashion, e.g. like CRT TVs to plasma to HD TVs to like VR, cell phones, etc. Entertainment groups need to be ready to adapt and deliver their media onto the new platform. I don't think it'll necessarily wipe out older mediums of delivery. People still read books, but it'll be a cool, I don't know. Yeah, I don't know much about it, but that sounds pretty cool. Okay, so thanks for being here. So 3 questions. What is the job market like for bioinformatics majors? So can I do quotes? Let's see, I'll just do markdown mode. So for bioinformatics majors, usually you can go into the software engineering industry or into biotech companies with a yes. You won't be leading research projects, but you'll get to be a member of various like project teams of interest. I have friends who have gone to like Google, to Illumina, to all these different companies. So yeah, with the bachelor's, I think the job market is pretty nice. Keep in mind you can apply to jobs in biotech, in like kind of pure CS traditional things, in like more bio-related fields, etc. So it's actually quite nice. You have like a pretty big range of places you can apply. So how often do bioinformatics majors delve into specializations of biology, such as neuroscience? I'm not too sure about neuroscience specifically, but yeah, we usually enter usually you'll enter some specialization. Usually, you'll enter some specialization. e.g., I'm in viral evolution epidemiology, my friends are in cancer genomics, some are in single cell, etc. So yeah, I don't know about neuroscience specifically, but yeah, I'm sure any niche of biology, you'll want someone with computational skills. Ooh, that's a good one. So what do I love about the field or scope of biology? I love that, what I love is how interdisciplinary it is, right? You have a problem that there's some elegant solution that relies on like computation, biology, chemistry, math, statistics, you know, all these different subjects kind of blend together. So yeah, to really push science forward, you get to bring together all these different disciplines that you get to bring together. So many different disciplines, e.g. computation, biology, chemistry, physics, math, stats, etc., to solve a single important problem. And post. Yay, okay. Is BIM 184 ever going to be taught again? So probably not. So the person that usually teaches it, or used to teach it, Sergey Pon, the prof who used to teach it, moved to Temple University a few years back. Actually, I was the first class of people after he was leaving, so I didn't get to take it either. But I don't know if they're planning on having someone new teach it. Yeah, Sergey's a cool person. I was potentially going to do a postdoc in his lab. He's really cool. Cool. Okay, so Niema is the goat. Aw, thank you. That's so nice. Pretty sure I met you freshman year. A mutual friend already said that at that point you've already a really smart dude. What made you go into academia instead of privatized route, given how wide the pay disparity, Susie? So that's a great question. Yeah, so in general, I think with bioinformatics, there's kind of this like, do I go into academia or do I go into industry? I think computer science as well, like you have the same question. And usually industry, it's like more money, a little bit, you know, you get to work on like bleeding edge projects that are gonna hopefully be turned into a product. Academia, usually it's less pay, but you have a bit more freedom. So I think the trade-off is really freedom versus versus pay. In industry, you can work on cool projects, but they all need to somehow translate into a product of some sort. Whereas in academia, you get to work on pretty much anything you think is interesting. It needs to be like reasonable so that you can actually get funding for it. So it can't be like some super, super far off idea. But it doesn't necessarily have to be tied to a product. Like I can just motivate, like theoretically someone could use it in this way. Whereas in industry, I really have to show like, this is the specific product that I can make with it. But you don't need to tie it down to a specific, like minimum viable. I don't know if people know the acronym. So minimum viable to a specific product. I also really love teaching. So yeah, one of the big reasons was I didn't want a job that I kind of just go in, do work, and then come home. Like I really love, you know, teaching, interacting with students, trying to figure out like, how can I optimize learning? Can I make sure that students learn the most information in the least amount of time? I also like my flexible, somewhat flexible schedule. Yeah, in industry, you're pretty much going to be working a 9 to 4, 9 to 5, or whatever it is. But I like kind of planning my own schedule. Like I can set my meetings whenever I want, as long as I'm doing the work I need to do. It's kind of at my own pace. Oh, Spice Beamer is back. Oh man. What do you think next year at UCSD will look like, considering that we already know fall is going to consist of mostly virtual classes? Ooh, that's a great question. So I actually honestly have no idea. Yeah, looking at the COVID numbers, I definitely don't think fall should be in person, which it seems not to be. But, you know, I'm not convinced that we're going to get it under control by the time winter gets here. Convinced we'll have things under control by winter. Hopefully. Oh, it's not capitalized. But the curves of COVID cases in California and San Diego specifically are still rising steadily. Though we do have better testing now, which is nice. Maybe if a vaccine gets developed, it'll be okay to do in person in winter. Yeah, so I think it's all kind of up in the air. It depends on how the science of COVID progresses. But if things are how they are currently or keep going at what's happening now, I don't personally think it would be a good idea. Oops. Okay, so how has teaching online in spring differed from teaching in person? Do you think there's a difference between online learning versus in person in terms of quality of education? Ooh, so I actually gave a TEDx talk on this a couple years back. So definitely watch that. I think it's on my website. In general, I think online learning gives you this opportunity, online learning, it gives you this opportunity, so online learning gives you an opportunity to personalize learning extensively. I never understood, like, how can we expect everyone to learn at the same pace? Expect people to learn at the same pace with the same amount of instructor interaction. For me, maybe I don't need as much time in a computational class. Oh, actually, that's another thing, for every class, right? So like me, I was bioinformatics, so in my computer science classes, I was really good at computer science, so I didn't really need as much time. So like an hour-long lecture 3 days a week wasn't necessarily the best use of my time. But for biology, I was terrible at biology. I just couldn't memorize everything as well as I should. And what's weird is I had no choice of like managing my time differently. Like ideally, if I have two classes, one of them being like a computer science class and one being a bio class, and I'm personally better at computer science, why do I have to spend the same amount of time on both classes when theoretically for me, a better learning environment would be less time on the CS class, more time on the bio class, but same total amount of time. What you miss out on, though, is the human interaction. The professors are hopefully good at, you know, taking your response to a question and determining where your learning breakdown or misconception occurred. That's really what you're getting out of your college education, right? It's this interaction with an expert that can design assessments to best trigger your learning. And like, if you have a misconception, hopefully answer it in a way that like they can identify what the misconception was and help you get over it. So that's something that you miss out on a little bit with online, with like the online learning. Like I can't face-to-face talk to you and like play off your body language. But we're getting to the point that online learning is being improved using new technologies. And then the last part was, are you gonna drop, when am I gonna drop my next music video? An artist never spoils the hype. Next music video coming soon. Oh, someone who graduated with me, that's cool. Yeah, so I graduated from UCSD in 2015. I had a Facebook group for sharing textbooks. Nice, yeah. Free textbooks Or yeah. I'll just upload that one. Yep, wrote a textbook that I give out. Yeah, and in general, I think education should be publicly accessible. I feel like I shouldn't be artificially barring content from people. So my textbook, when I wrote it, I like posted on the internet immediately. It's available for free. It's also on Amazon for people that want a physical book, but it's printed at cost. So I think I make like a quarter per physical copy that's sold, or like something like that. So it's not worth, like I don't benefit from people buying it, but it's purely just hopefully people can learn however they want. Why does bioinformatics have 3 separate streams? So I have no idea. It was kind of like that ever since I started when I was an undergrad. It actually used to have 4 separate streams. It used to have a chemistry one as well. I have no idea why we have a different version of it in different departments. Yeah, so if someone still remembers chem bioinformatics. Yeah, so I have no idea. I think it's just purely historical. Is there ever going to be a chance of bioinformatics having its own department, judging that we have such strong faculty? I hope so. I don't know if I hope so or if I just, yeah, I would have to see. So the problem with getting a separate department would be that faculty members would basically have to leave their existing departments, which might be a headache paperwork-wise. It might make it weird for things like tenure. Like instead of moving people to that separate department, do we hire them as partial, like 50% computer science department, 50% bioinformatics? I don't think bioinformatics has enough classes yet, and like as enough of a base to have its own department yet. I don't think it's big enough yet to have its own department, e.g. all of our undergrad classes, except CSE, Bang, BIM, 180, I guess 180 through 186. Well, actually math is 186. All right, are part of other programs. So yeah, so I think faculty-wise, we have strong faculty, which is why we have the bioinformatics PhD program, which is interdepartmental. But yeah, for a department, I think there's a lot more administrative stuff that might get in the way of it. What are ways to start up bioinformatics research early as an undergrad? Definitely reach out to faculty members you're interested. Look through the bioinformatics faculty list, and if any research topics catch your eye, just let them know you're interested. Send them your resume or whatever skills you have, and ask if there's any potential projects you can work on. And I'll link to the bioinformatics page. Bioinformatics.ucsdu. Faculty. Can I copy the, I'll just copy it from here. There we go. Let's switch to the fancy pants editor. There we go. Reply. Yeah, so just email them. A lot of them are going to say no, unfortunately, just because they might not have time. A lot of them might not even respond, but all you need is the one person to say yes. It's a lot of funding, red tape. Oh, okay, yeah, that's pretty much my answer here. Nice. Cold call emails. +1 to this. Yeah, I just kind of skimmed it, but yeah, this sounds pretty much like what I'm saying. Okay. So what are the most useful classes that I took in undergrad or grad school that I still draw knowledge from today? So this is biased because I'm bioinformatics, but definitely CSE 181. It's basically a foundations of bioinformatics algorithms class. And any topic I've ever faced in bioinformatics, the fundamentals of the algorithm they use somehow stems from something I learned in this class. It's a super intense course. You're getting 10 weeks of basically the entire introduction to bioinformatics, but you learn the entire introduction to bioinformatics in 10 weeks, so super helpful. What skills do you think bioinformaticians should know but aren't part of the major requirements? I think bioinformatics is more so a broad umbrella term, and within it, there's many niches. E.g., I'm in viral immunology, phylogenetics. There's way too many subject areas to learn the bioinformatics of each one. So it makes sense just to like learn the basics from the major and then pick a field that you're interested in and like really learn the specifics of that field. So it's best to find what you're interested in and really hone in on the specifics of that field. Learning papers is a great skill if you were looking for something concrete. Yeah, so, oops, not learning papers. Reading papers. Reading scientific papers, that's a skill that I never really learned in my undergrad classes, but it's a super great skill to have. In what cases do I recommend someone go to a master's in bioinformatics versus a PhD? A PhD is really a research degree. The coursework is usually somewhat minimal, so you should only pursue a PhD if you really want to do research. If you're more so looking for a stepping stone to, like more management level positions, e.g. project manager or similar industry, but you don't like research, I definitely wouldn't recommend a PhD. Yeah, like you really have to want to be able to do research. Yeah, so definitely try out research in undergrad, if at all possible, to see how you feel about it. And reply. Okay. Someone met me at a kickback in undergrad. Oh man. Wow. Yeah, so I did my undergrad at UCSD as well. That's funny. Different girlfriend now, but yeah. Yo, what happened in the game? You can't tease us. You can neither confirm nor deny any allegations. Let's see. So, hey, Niema, I'm Bioinformatics class of 2017. What do you see as the future of the undergraduate bioinformatics curriculum at UCSD? You see the curriculum evolving as the field does. I definitely see the field evolving, the curriculum evolving as the field evolves and as we get more faculty members who do bioinformatics research who also teach undergraduate classes. So for example, up until Melissa Jimrek was hired, we didn't have CSE 185. And then when she came, she created that class and that became, or did we have CSE 185? Wait, we had it 1 year. So when I was an undergrad, it got canceled, I think. And then it came back in the future. But in general, her version of it, yeah, no, we did have it. Sorry, I'm totally misspeaking. We had it for quite a few years, but her version of it is completely revamped. Like it focuses a lot on like population genetics and stuff like that. So I think what I hope to see is as more faculty join, I'll say more bioinformatics faculty join, we'll get to have more bioinformatics special like niche topics to choose from as bioinformatics electives or something similar to how in biology or CS, etc., you can pick subject areas in which to specialize. Because yeah, learning bioinformatics from like 5 courses is not actually learning bioinformatics. Like I learned nothing about phylogenetics, and even now there's not really a phylogenetics class that you can take in undergrad. So my entire field just does not exist at the undergrad level. So it'd be cool to have like different faculty members teach their research area. For example, considering recent advances, blah, blah. Just like with other fields where we keep fundamentals as the intro classes, I think they should still exist, but there should also be more advanced or like niche classes. Okay. It seems that I've had recent manuscripts on bioRxiv. How does it work to be a teaching professor and conducting research? That's a great question. Yeah, so I think most of the other teaching faculty do education related research. So like what are effective teaching interventions? What are effective ways of styling the curriculum? What are disparities that we see between different populations, all related to like CS education. Whereas I mainly continue my bioinformatics research. As a teaching faculty, I don't really take on grad students. I haven't yet, and I don't really plan on doing it, but I have a lot of undergrads working with me. And you can check them out on my website. If you go to my website, you can see a list of some of the different students that have worked with me. Yeah. But lots of things are still a one Niema show. So most of my like algorithmic stuff is still just, I'm interested in doing the research and I just kind of do it. I don't have a firm understanding about bioinformatics, but there's a few questions. What are you most excited about with regard to distance learning? Yeah, so that one kind of like above, super interested in the potential, super excited about the potential for personalized learning, e.g. at your own pace. What are you most nervous about with regard to the distance-based learning? How can students make the transition smoother and perhaps more as impactful as in-person classes? So one worry I have is that it doesn't feel like faculty, or not faculty, it doesn't really feel like there was as much investment in the transition as I would have liked. I'm personally good at this stuff. So like for me, I already had experience with like recording online videos, like how do I do video editing, things like that. But for like the less tech savvy faculty, there wasn't really much push to like train them and things like that. But there weren't many resources initially beyond funding. We were given money to help transition our courses. But beyond funding, So we were given funding, but not really training to transition courses to online in spring. CS seems to have done relatively well, but in general, I think all departments could have done this better. And it's not like the department's faults either. It was really, campus was on this kind of, are we going online? Are we not going online? Like tightrope for a while. So we didn't know for sure we were going online until soon before, but it would have been nice if we just assumed doomsday and like prep for online, even if we thought we were going to be in person. But either way, I hope that now that we've had spring and all of summer to prep, fall quarter will be better designed. And then as far as advice for students, I think it's essential to actually schedule out when you'll be working on things. So normally you block out your lecture times, maybe discussion times, but maybe not as much time for other homework or assessments, learning. But for remote learning, especially if faculty have their classes asynchronous, it's important to like make time to review things on your own. No, not yeah. So scheduling, I think, is super important. It's easy to get lost when you don't have your fixed. I'm on campus. I go to this lecture. I come home, go to the other lecture. So yeah. So how has COVID-19 impacted your research in the bioinformatics field? Are the parts of the research done? Oh, that's a great question. So my research is in viral evolution and epidemiology, which is usually somewhat of interest because of HIV, but COVID-19 threw my research area front and center. So it's been way more busy than usual. It's good problems to have. I feel like it's nice that my research area is kind of in demand right now. So I got grant funding, like not too difficultly. I've been able to have some students working with me, but I never get to rest because there's always something to do. Fortunately, bioinformatics research, at least in the more computational side, can be done remotely. So my research hasn't been negatively impacted by by the quarantine and, whoops, I spelled quarantine. The quarantine, and it's actually become super productive. I want more free time for video games though. Yeah, so I like never have free time anymore. That's kind of sad. Yeah, that was a great question. What's my favorite taco place in Chula Vista? Gotta give my buddy Javier a quick plug for his restaurant, El Güero, too. Definitely check them out. Yeah, so one of the, whoops, not that one. One of the perks of being from San Diego is that a good number of my friends from high school have gone on to, what is it? It doesn't really let me copy links that well. I've gone on to own, like to run taco shops. So this is my buddy's taco shop. Gonna give him a quick plug. They cater to UCSD, so if we go in person, definitely check them out for catering options. Let them know that Niema sent you.
I think we should move to the Google form now.
Oh, sorry, shoot. Okay. Okay, so I'll come back to this after if there's still time. Whoops, did I not see something in the chat? Okay, yeah, so I'll move to the Google form for now, but I'll come back to Reddit after just in case. Okay, so for the Google form questions, what would you say is the most important factor when applying to bioinformatics graduate school? In general, any, well, so it depends, first of all, what type of graduate school. If it's a master's versus a PhD, like PhD, all they care about is, are you going to be able to do, good research? Like if you join their program, can you do research successfully? So most important thing would be to highlight actual research experience you have in undergrad, if there is any. If you don't have very much research experience, maybe emphasize things you've done in classes that could be like a stepping stone to research, any independent projects, things like that. For a master's degree and then somewhat for a PhD, you want to hope to have like a decently good GPA. It doesn't have to be perfect. Bad grades, especially early on in undergrad, are like totally understandable. But you want to somehow evoke that you're dependable and can get a job done. And I think if you have like a really low GPA that you can't really explain, you'll have to compensate a lot more strongly with research background. And you'll have to like explicitly mention like, hey, even though I'm hardworking and even though I can do successful work, these are the factors that led to my bad grades. So I think grades are secondary. You just kind of want to mention them if they're like especially of note, something that you're a little bit weak in, but mainly research. What made you decide you wanted to go to grad school? That's a great question. So I had a lot of research experience in undergrad, which I highly recommend to everyone. You might like it, you might not like it, but you won't know until you try. I really liked research, so I decided, I want to keep doing research in this field, and a PhD was really the natural place to kind of focus on learning how to do research well. I also kind of knew that I wanted to be a teaching faculty of some sort, either a teaching professor at like a research institute or a regular professor at like a smaller institution, like, like a state school or at like the McKenna colleges or like a liberal arts school. I knew I wanted a teaching focused position, but at higher education. And usually you need a PhD for that. How difficult is the job hunting experience for bioinformatics after completing graduate school? I don't know if this will be generally true in the future, but in the past few years, it's been quite nice. I think computer science and bioinformatics in general are very hot fields right now. None of my friends had any trouble getting a job in bioinformatics after graduate school. And so usually you'll have a job lined up before you graduate, so you don't have to really have a lapse in money. So usually like when you set your PhD defense or I don't know about master's actually, I'm mainly talking about PhD here. But when you set your thesis defense for your PhD, it's because you have a job lined up and you've done enough stuff, not just because you're like ready to graduate. So yeah, not too bad. What career options were you considering at the end of your PhD? Great question. So at the end of a bioinformatics PhD or a computer science PhD, really you have kind of a few different areas. You can look into a research-focused professor, so a ladder-ranked professor at a research institution. You can look into doing a postdoc if you know you want to be a research professor at some point, but you don't really feel like your research profile is kind of strong enough. Most people go into a postdoc before doing a research professorship. So usually it's a postdoc. You're going down like the academic research route. You can go into like a teaching focused position. So as I mentioned, teaching faculty at a research institution, a professor at a liberal arts school, at a state school, things like that. If you don't want to go into academia, there's also research institutes. So you could work at like Lawrence Livermore National Laboratories. You could work at Los Alamos National Laboratories, like the Salk Institute. There's a lot of research institutes that do research, but without being necessarily a degree-serving institution. Like they're not necessarily a school. Just like with the research professor route, you'll probably want to do a postdoc first. And then the last route, which is a very popular one in bioinformatics, is going into industry. So a lot of bioinformatics jobs at biotech companies need a PhD because you don't really have the subject matter expertise after a bachelor's to do like experimental design, like push the sequencing technologies to the next level, things like that. So there's plenty of jobs in industry, both in biotech industry as well as in like traditional computation industry. So like in biotech, you're looking at like Illumina, Genentech, like all those biotech companies. In the regular CS world, you're looking at like Google, Microsoft, IBM. They all usually also recruit from bioinformatics. Okay, so for a person who majored in bioinformatics as an undergraduate, what are pros and cons for majoring in CS versus biology versus bioinformatics in graduate school? What programs are best fit for bioinformaticians, aside from bioinformatics, of course? So I think really I want to separate graduate school as like master's versus PhD because they are two very, very different degrees. So for a PhD, the name of your PhD doesn't really matter. All that matters is what departments are professors that you want to do research with. So like for example, my PI, my advisor in my PhD, his name's Siavash Mirarab. He's in the ECE department. So I am by no means an electrical engineer. I don't know anything about hardware pretty much. But he just happens to be in the electrical engineering department. So that's technically my main department when I was in my PhD. And a lot of his students are from the ECE program, even though they do like purely bioinformatics algorithm stuff. So in general, if it's a PhD, it doesn't matter what the program name is. You just want to look for what faculty members you would want to join and apply for whatever program they're a part of. For a master's, I think it depends what you want to do. Bioinformatics is really like a spectrum. You have biology, you have computer science. I'm more on the computer science side. I don't really do any wet lab stuff. Sometimes I'll analyze real data sets, but it's mainly theoretical and tool building. Versus there's some people that are like almost entirely biologists that they're using computational tools to analyze new biological questions. So if you find yourself more on the, I want to answer biology questions just using tools, maybe bio or genetics programs would be more relevant. But if you're more interested in like developing algorithms, developing methods, and you don't really care what specific area they're applied to, you just want to apply them somewhere in biology, probably more on the CS side. Stats would also be maybe a relevant fit, depending on what you want to do. So does participating in bioinformatics competitions help with applying to grad school? I don't know what a bioinformatics competition is. So no idea. In general, so again, PhD versus master's, recall my question, my answer here. For a PhD, research experience or anything that shows you can do cool projects is something you want to showcase. If this is like a hackathon you're referring to, I think that would fit nicely in the, here's a cool project I can work on. So I would say, assuming this is like some hackathon type thing, it'll probably help, I think. How early should you get invested in the grad school process? Well, first of all, you have to determine if you want to apply to a master's versus a PhD, if you definitely want to go to grad school. And even before that, you have to figure out, do I want to go to grad school? So the do I want to go to grad school question, I think start thinking about it at the end of maybe freshman year, once you've had a little bit of college experience, but you really don't know that early. Like you won't really know until your senior year really. So maybe like throughout your junior year is when you should be really doing soul searching to see like, do I want to go to grad school? What types of programs do I want to go to? Yeah. So like my history, I was actually pre-med all of undergrad. I was a human bio major, and then freshman year I switched to bioinformatics. And I actually was pre-med all the way out, took the MCAT, applied to med schools. Didn't get in, unfortunately, or fortunately, depending on how you look at it. But it was my like junior and senior year that I realized like, oh, I really like algorithms and bioinformatics stuff. Maybe I should just specialize in that. So it was pretty much my senior year that I shifted towards, oh, I want to do a PhD instead. So it's never too late. So yeah, I wouldn't really worry about how early, just however early you can think about stuff is better. Give yourself as much time as you want. Is it better to get industrial or work experience before pursuing grad school? I think so. So as someone that never had a job between any of my stages, like I had a job on campus when I was an undergrad, just like a IT job, but like I never went into my industry before going back for grad school. Um, I do think if you're curious about industry though, it would be good to get some experience. One thing I will note though is that it's fairly common for computer science or or bioinformatics PhD programs to let you do industry internships over the summer. So like a lot of my friends in the bioinformatics program did internships at Illumina. I know a CS PhD student who's doing an internship, I think at like Microsoft or something right now. Um, so even if you don't get industry experience before going to grad school, if you're curious about it, you could do internships to see. But I think it is a good idea. It's not for everyone. It wasn't the right choice for me. I wouldn't have wanted to go into industry because I knew I didn't really want to go into industry. But yeah, depending on you, if you're up in the air. How do you know which path in computing? I don't know what the question was supposed to be, but I think everyone has their own path in computing. So just do whatever works for you. A lot of my computer science skills I gained because I like retro gaming and, wanting to do things like manage a file system containing all of my like old school NES ROMs and bulk renaming them to get things looking correctly, bulk compressing them, analyzing them to extract metadata in an automated fashion, like something that has nothing to do with bioinformatics or like traditional CS. It was just stuff that I was interested in that I picked up. Would you ever leave UCSD? Nope. I love UCSD. Maybe, we'll see in the future, but I can't really envision it. Like I love San Diego. I'm from San Diego, so. How do you balance private and public life, especially with Reddit and social media? It gets kind of hard. I don't know. I feel like, I don't know. Everything that I post on Reddit and on Twitter and things like that, I assume that people know it's me and people know I'm a professor. Versus things like Facebook, Instagram, I mainly treat it as like, this is for my friends and family and stuff like that. What's hard is my phone gets notifications from everything. So it's like jumping between these different mindsets. But I think it's mainly just a matter of like, I stop checking the ones that are the Professor Niema side of things at a certain hour of the day just to like have free time. But kind of flipping that hat as I need. What type of research is conducted in bioinformatics at UCSD? I can't do that question justice. I would say go to the bioinformatics website. It's bioinformatics.ucsd.edu. Go to the faculty list, and we have a ton of awesome faculty members in the bioinformatics program that do all kinds of research. And then if you find any of them interesting, feel free to like click on their website and then learn more about it, like research. Yeah. Whoops. Okay. How would I know if research in academia or in industry is the right choice for me? Definitely while you're an undergrad, get research experience. You don't need too much research experience. I would say everyone should get at least 1 quarter of research experience just to know, do I like it or do I not like it? You could do a CSE 199 or like whatever department you're in 199 to get course credit for your research experience if you want to get compensated, which everyone should definitely get compensated. I would definitely recommend everyone does research at least once. For industry, it would be good if you tried to get some internship experience at some point, either in one of your summers or if you could do like some UCSD internship of some sort. I don't know. But really the only way to know which one's for you is by trying both and see which one you like more. How was my experience as an undergrad? I liked it a lot. I think UCSD is a really big school, so that was a little overwhelming when I first started. The campus is massive and like so many different lecture halls, so many different majors. So it was kind of easy to get lost my first year, but I had my kind of support system of my good friends that I met. So it became a lot better as I went on. I really enjoyed it. I think the big classes are it's unfortunate, but I think the trade-off of big classes versus I get to learn from like really, really expert people in their field, it was pretty cool for me. and I love San Diego. How might bioinformatics help a pre-med student prepare for a career in medicine? That's a good question that might be good to like ask a med person a little more. So for your pre-med requirements, I think the bioinformatics major covers most of the pre-med requirements as far as courses go. I think medicine is starting to push towards like needing to know a bit about computation, or at least about what is bioinformatics. Because like you can't really understand the molecular basis of disease if you don't understand how to analyze molecular data, which you need bioinformatics to do. But for getting into med school, which is like its own beast, as someone who applied to med school and didn't get in, I'm not necessarily certain there's very much overlap between what helps you be a good bioinformatician and what helps you get into med school. So I think one of the biggest things that was lacking on my med school app was that I didn't have any, or I had like very little hospital volunteer work and like shadowing experience, which would not help me very much in bioinformatics. But for med school, I think they were really looking for someone that was like volunteering in a hospital or something like that. So definitely talk to the pre-med people. Talk to like the med counselors. Incoming third year, should I self-study Python or R? So in general, I think, so the language debate, I think pick one language that you want to learn and get really good at that one language. I think people try to learn a bunch of different languages and become kind of mediocre in a bunch of different things. It's much more useful to be really good at one language and then be able to do a bunch of stuff with it. So I personally like Python the most, just because everything I've ever wanted to do in R, I could also do in Python. It's a scripted language. It's got easy syntax. It's cross-platform. So if you don't know any of them, I would personally recommend Python, but doesn't really matter. What else can I do? I think the biggest thing is just keep getting good at Python, or whatever, or R if you pick R. One thing that I think is a very useful skill for any computational person is the ability to go from raw data to a visualization in as little time as possible. So be comfortable with like visualization toolkits in whatever language you pick, know how to read files, parse them, and then like create a histogram or create a box plot or whatever you need to create. So once you get good at Python syntax, get good at like some of the important packages. So like matplotlib, or Seaborn I like using for visualization, getting good at NumPy, getting good at SciPy, pandas. Yeah, I would just hone in really well on the language. How useful is organic chemistry? And why is the answer not? Yeah, so I've never used organic chemistry ever. And I really hate that I took all 3 organic chemistry classes and organic chemistry lab because I was a pre-med. So yeah, you're probably, unless I'm missing like a very specific niche, I think some of the principles like, you know, like the fact that DNA, like what is a peptide bond versus what is a hydrogen bond. I think it's important to know the molecular structure of those things, or not molecular, like the atomic structure of those things, just to really know why is DNA attracted, why does it split apart if we heat it and stuff like that, or if we change the pH. But beyond like what you learn in intro chemistry or intro build, I don't think it's super helpful. How to run a simple research project and or apply for biotech industry. Applying for internships is very hard your first year. So if you applied for some and you didn't get into any after your first year, definitely don't be disheartened. As you mentioned, you don't have very much experience yet. I think a good route is, if you're early on in college, try to do a research project with a faculty member. So like just reach out to someone that does stuff that's relevant to what you want, and try to do like a CSE 199 or whatever research area 199. You get course credit for it. It usually counts as an elective, and you get like 1 quarter where you're mentored by a faculty advisor. I think once you have 1 experience under your belt, it's much easier to apply for internships. So yeah, so if you only have a couple classes, maybe lean more towards research projects. You think an undergraduate bioinformatics division at UCSD sufficiently equips students to work at the bioinformatics industry? Yes, surprisingly so. So I was a little bit skeptical when I was an undergrad because I felt like I was taking classes all over the place. Like, here's you know, organic chemistry, here's algorithms, here's data structures, here's molecular biology, like all these different classes. But it wasn't until I hit my grad school applications and like also started collaborating with people in the industry that I realized the undergraduate bioinformatics major at UCSD, it teaches you enough biology to be able to, discuss with the best of biologists. It teaches you enough computer science to be able to discuss with computer scientists. It teaches you enough stats to be able to discuss with, stats people. So it does it's a very difficult major in my opinion. It has a lot of classes. We take the bio majors, bio class, the CS majors, CS classes, the chemistry majors, chem and OChem classes, the physics majors, or maybe not physics majors, the engineering physics classes. But when you come out of it, you really have a strong foundation in pretty much everything. So interdisciplinary field, how well does it translate into job prospects? So I think this is really up to the individual. So I had a lot of friends that were bioinformatics majors, but did a lot of like software engineering projects or more computer science focused. I had some that were more bio focused and worked in a wet lab. So I think the curriculum is one aspect, but what kind of extracurriculars you choose to get, what research experiences, internships, I think those are what most strongly dictate what type of job you would get. How do you compare it to a biology major for a lab not involving programming? Oh, I see what you mean. So compared to a CS major doing a programming job, like programming is easy, comparatively. Like compared to the other stuff that a CS major takes in a CS major versus the bioinformatics stuff that we do in a bioinformatics major, like let's say it's a CS person that does architecture and a bioinformatics person that does like algorithms, like bioinformatics algorithms. Programming is a very simple overlap of both of those fields. So if you want to go into a software engineering job, I don't think you're at any disadvantage if you're a bioinformatics major versus if you were a CS major. I think maybe try to take like CSE 110 if you want a software engineering job, which is the software engineering course. But beyond that, like you have the core intro programming, data structures, advanced data structures, discrete math. Yeah, so I think you're pretty well off. Compared to biologists, I don't think we're necessarily as ready for wet lab jobs if you choose to take the bare minimum number of lab classes that we have to take. I think we just take Build 4 and BIM 101, if I'm not mistaken. I think I also took BIBC 102. So I didn't get very much wet lab experience, so I was always like puncturing my gels, and like I would miss with my pipette. I would contaminate my samples. So I was very terrible in the lab. And I think we just don't get very much experience with it. But again, if you did a bioinformatics major and then did research in a wet lab, I think that would make you perfectly sufficient for a biology job as well. So it really depends on your extracurriculars. Which minor works best for bioinformatics major? I did an econ minor and it was pretty easy. I had to take Build 1, 2, 3 for letter grades. And then it was any 5 operative econ classes, or not Build. I took econ 1, 2, 3 for letter grade, and then any 5 operative econ classes that could be pass, no pass. And I actually did a research project in econ. So that one was like not too hard of one. And I like knowing about economics because I feel like it's relevant for business stuff. But aside from that, I don't think there's really like a good minor for bioinformatics major. I think just whatever you're interested in doing, get a minor that complements that well. If you're interested in going to business, maybe a business minor, an econ minor. If you're interested in going to like more wet lab stuff, or you want to know the wet lab, maybe go into a bio minor if they let you. I don't know if they let you do a bio minor. Yeah, so I don't really have a good answer for that. Is the bioinformatics program better as a CS major or a bio major? I'm actually not too certain about the differences between them. I would imagine if you want to do more computational bioinformatics, the CS one would be better versus more biology stuff. The bio version would be better, but I'm not too sure. UBIC people would be the best to answer that question. How do computer science and statistics weigh in this major? So I don't think we take very many stats classes in the bioinformatics major. There was just Math 186, and technically, if you count discrete math as statistics, you take CSE 21. But it wasn't super integral when I was an undergrad. But when I graduated and did graduate research, statistics became like essential to everything that I do. So I think the stats are important in things that you'll be doing with your major, but I don't know how much you'll be using them actively during the major. Computer science, you're going to use all throughout, though. Okay. Do you see bioinformatics as an independent field study or an extension of biology or computer science? I think once you get to a certain point in a certain field, like a certain level of advanced, these boundaries kind of disappear, right? Like, what is computer science even? So for example, I do computer science from a purely theoretical aspect versus I'm collaborating with this professor, Tiana Rosing, who's in architecture. Everything she does is hardware, and she doesn't do very much algorithm stuff. And I don't do any hardware stuff, but these are both considered computer science. Versus separately, you might have someone in software engineering that, again, does something completely tangential to either of us. So I think these categories of like, what is computer science, what is biology, what is bioinformatics, I think these are all just arbitrary names. And I think bioinformatics would be more so a mix of biology and computer science topics, but even biology. Like, is computational biology biology? If you're more on the bio side of it, I think so. Like, if you're doing a wet lab and you do your own data analysis, I think that's all biology. But really, that data analysis portion is bioinformatics. So I see all of them as kind of blurry blobs that overlap significantly. What is a typical bioinformatician's work life? Depends what aspect of your life you're in. So when I was in my PhD, I liked sleeping in and I liked staying up late coding. So I would basically wake up at like 11 or so, just do my research stuff all day, and then, watch some TV at night and go to bed kind of like super late. Nowadays, now that I've been a faculty member and I try to like keep my schedule open during the day that people want to have meetings and stuff, usually I'll like wake up in the morning, do a little bit of coding, do a little bit of data analysis, respond to emails, respond to more emails, respond to more emails, Zoom meeting, Zoom meeting, Zoom meeting, Zoom meeting. I'm just kidding. But yeah, usually it depends what type of industry you're in. If you're in like a software engineering role, maybe you'll be doing more software engineering and coding stuff. If you're doing more data analysis, maybe it'll be like running workflows, checking on the results, visualizing them. Yeah, it depends what area of bioinformatics you're in. What do you think the future of bioinformatics will be like? So I feel like bioinformatics one day will become kind of like one of those fundamental topics that they teach everybody, right? So like everyone at some point takes an intro bio class and learns like, what is DNA? What is the cell? What are the parts of the cell? Golgi, wait, what is it? Isn't the Golgi the powerhouse of the cell or whatever? Oh, mitochondria, what am I doing? Ooh, and I'm being recorded. Wow. Mitochondria is the powerhouse of the cell. That's how little I work with biology, just kidding. Yes, I'm hoping like in elementary school, they'll teach like intro to bioinformatics where you like do a sequencing experiment and learn about like Sanger sequencing. So yeah, that's what I really hope the future will look like. Just still continuing the upward flow of like expanding it, but especially growing downward into like K-12 education. How is diversity like in the field of bioinformatics, for example, neuroscience? So like, I'm not sure if you mean like gender diversity or like ethnic diversity, but I'll assume that's what you meant. In general, I think STEM is very, I don't know, it's not very diverse as a field. And I think it takes everyone in the field to help make it more diverse. You have to kind of lower systemic barriers that disproportionately impact people. But in its current stage, I don't really think either field is very diverse. I think bioinformatics historically seems to be a little bit more diverse than pure computer science. But that's just my own anecdotal, like what I'm thinking of off the top of my head. But I think there's plenty of room for improvement. So be the change you want to see in the world. Yeah. Oh, actually, and if anyone ever wants tips on like some things you can do to help make bioinformatics a little bit more diverse, feel free to reach out to me. I'm a part of a few different kind of diversity focused initiatives, and any type of outreach is always helpful for these types of initiatives. Okay, how has my work in bioinformatics overlapped with coronavirus research? So my research is viral evolution. So it has completely transformed into coronavirus research. So what was that? Was that been, oh, my research history is funny. Okay, so I created this tool called Bioreport, which is a workflow that basically runs an automated analysis workflow on any given viral data set you give it. How do I go back? Just let me go back to this. There we go. And then I've been maintaining a somewhat real-time analysis of all COVID data, like all COVID sequences in the US. So like things like, if this is the genome, like what positions are, like what does the coverage look like? What is the entropy across the positions? I'm working on some projects where we're trying to accelerate the workflows. So yeah, pretty much my research has turned into coronavirus research. What do you think the next big thing is going to be? I assume in bioinformatics. So I think the next big thing is long read sequencing. So like nanopore sequencing used to be like Oxford nanopore, these types of things. They used to have really, really bad error rates, but they get really, really long reads. And I think the error rates are still pretty bad, but they're much better than they used to be. So if it keeps going at this kind of growth of quality, I think that will be the next groundbreaking thing. Because like so many computational problems in bioinformatics would just disappear. So there's like genome assembly. If we can just do super long sequencing, genome assembly is no longer a problem. I just sequence the whole chromosome. Haplotyping. So like, can I see what chromosome each mutation is actually physically on? That disappears because again, I just sequence an entire chromosome. So I think that'll be really the next groundbreaking thing. What did you find was the most useful programming language in bioinformatics? So I think that really depends on what you're going to be doing. So if you're doing data analytics, I think a scripting language like Python or R would be the most useful. Just because syntactically, they're the simplest to go from raw data to like visualization or summary statistics or something like that in as few keystrokes as possible. But a lot of people in bioinformatics do tool development. And usually these tools are written in C, C++, some compiled language for the sake of speed. So in general, I think the first rule is get really good at one language, and I would pick either Python, R, or one of these like simple scripting languages. And then my second rule would be once you get super good at that first language, it's good to know one scripting language and one compiled language, like really well. So for me, I'm really good at Python and C++. I think if you're good at both of those, it'll help you do things like, let me just write quick and dirty tools. And if it's good enough, I'm just going to keep it in Python. But then if I use it enough, and I think the speed up would be significant enough, then I will go back and rewrite it in C++. How prevalent is it in biomedical research today? I don't know what it refers to, but I assume it is bioinformatics. So if so, bioinformatics is pretty much the center of biomedical research today. Pretty much all biomedical research depends on doing a sequencing experiment of some sort, or like some type of molecular assay that you then have to analyze the data. So I think the questions are still bio or biomedical, but how do you actually probe those questions and come up with the answers? Computation is like integral to it. I don't mind taking a professorship, but I want to work in a biotech company developing therapeutic drugs and treatments for cancer or diseases like coronavirus, aiming for a senior or managing position. Which one of these three education plans is better? 2 BS in cell bio and bioinformatics, and then do a PhD, 1 BS and then a PhD, or 1 BS and then a PhD, but other BS. So in general, that's a great question. So first of all, get research experience first. Whenever I see someone say, I want this job, so what PhD should I get? It's always kind of a red flag, because I've known many, many people who pursued a PhD purely because they were interested in a job at the end of it, not really because they were interested in research. And if you don't genuinely enjoy the research, it's a very frustrating time, and you're going to have a really tough time in a PhD program. Like, you really, really need to want to do research, because that's what a PhD is. It's really a research degree. Judging by the first part of your question, though, it sounds like you are in that group of people that seems to like doing research, given that you're interested in working in a biotech company to develop therapeutics. But still, I would recommend get research experience first. Assuming you have research experience and you definitely want to do a PhD, I think all three of these plans are fine. I think you definitely want formal bioinformatics background if you want to do drug design and like cancer treatments, and especially if you want to do cancer diagnostics. Computational skills are essential there. But I don't really think there's one solid answer for you do a dual major versus. So I think if you did one major, I would say major in bioinformatics, because you will be taking a lot of the relevant cell bio that's related to, or like you can take the relevant classes related to drug therapeutics and cancer or virus therapeutics as your elective classes in a bioinformatics major. But really, you need the computational skills to do this well. So I would say if you only did one bachelor's, I would say the bioinformatics one would be the better one. If you chose to do both, or if you did bioinformatics major, like a bio minor, or if you just chose to take elective classes and not do a minor either, I think any of those would be equally fine. What really matters is your research experience. I learned very few of the things that I do nowadays from classes. I learned them pretty much entirely from research. The classes gave me the foundation from which I could learn, but really the learning itself was from research. Cool, how are we doing on time? Oh, whoops, I went way over. Sorry about that. But I can still hang around if people want to do Q&A. Yeah, so maybe I'll stop sharing here. Whoops, sorry about that. Oh, I didn't see any of these questions. Sorry, it wasn't notifying me. Let me take a quick look. Oh, David said hi. Hi, David. I think you might be gone by now. What do I think about coronavirus? And yeah, so sorry, I didn't see any of these questions. Okay, so what should we maybe just do live Q&A then, or should I read through the chat? Maybe one of the.
I think there's only a couple of questions in the chat, so if you want to do live, we can do the live Q&A.
Okay, yeah, let's go ahead and do the live Q&A, and if you asked a question in the chat, like feel free to just re-ask it live.
Yeah, so I guess if you have a live one, just like raise your hand in the chat, and then I can just unmute.
Oh, I think Michael has a question.
Hey, can you hear me?
Hey, yeah.
Cool. By the way, I took your CSE 100 class last spring, so
oh, nice.
You were my favorite CS professor, so yes. Thanks for that.
Yeah, thank you. Thanks for the kind words.
Yeah, no problem. So my question is, it's about coronavirus in the US. I asked it in the chat, but I'll re-ask it. So right now, it kind of feels like there's literally no plan, like, because with quarantine, you know, it's like a limbo-ish quarantine, and, you know, the death rate's not as high as it could be, but we're not really reducing coronavirus, or like we're not going to end it really like this. And also having it burn through the whole population, obviously no one likes that plan anymore. And it just seems like there is no plan whatsoever other than maybe waiting for a vaccine. So just kind of what do you think of that, and what do you think a potential plan could be that would work?
Ooh, that's a great question. So let me first pull up a link that I always refer to. Shoot, where is it? What's it called? Worldometer. And I'll share my screen again. So I really recommend checking out this site if you want to keep up to date with just the raw numbers in the world, in the US. So they have it by country. You can then go by state if you want. So one thing that actually kind of worries me is, so the recorded cases, it's like 4.8 million. Deaths is like 158,000. The recovered number, I'm assuming there's a lot of missing data. So let's even assume that only deaths were recorded, and every this minus this are people that lived, even though really some of them probably didn't recover, but let's assume for the sake of like just a safe assumption. So 4,858,641 minus 158,892 is like 4.6 million roughly, 4.7 million. And then if I divide that by the total again, 4,858,641, that's like a 96.7% survival rate, which means like a 3.3% death rate. So the death rate's actually kind of bad. The number is definitely, it's not uniform. It's biased towards older adults, but still, it's actually a pretty big number, especially at the rate that COVID's growing. So I think one thing that's been like kind of frustrating me is that it's somehow turned into like a political thing. Like if we just did things properly from a public health perspective, literally week one, like everyone saw this coming a mile away. So I myself, I have like text records from when I texted my parents, I think in late February. So I was tracking the COVID sequences being deposited on this public database. And even I could tell, like, I saw the growth of it in China, and then I saw the growth of it in Europe, and I saw it starting to grow in the US, and I was like, wait a minute, uh-oh. So like I called my parents and I said like, hey, you should stock up on like non-perishable foods, because I think like grocery stores are probably going to run out of food like if people start panicking soon. And it did. So that was like back in late February that I knew this was coming. So I think my biggest frustration is just, yeah, our government kind of, I don't know, they didn't react as well as they should have. So now as far as UCSD is concerned, I'm glad that they have better testing now. I don't know how good it's going to be. I personally still don't feel comfortable physically going to campus in a closed lecture hall. Yeah, but I hope things are getting better. California is still growing super rapidly though. Yeah, so I don't know if that really answered your question, but I think my main response would be I'm a little bit pessimistic as to what can be done at this point. So I think what hopefully will happen is if local governments can instate mask wearing mandates, that would be a good first step. I walk in my neighborhood like pretty much every day just to get a few steps in, and like I would say maybe 10% of the people are wearing masks, which is really frustrating because that's the easiest way to prevent the spread. Yeah, so I think that would be my number one action item that the US can do, is like have local governments instate mask wearing mandates, actually punish people that are violating the quarantine by giving tickets, or like somehow put their money where their mouth is, as far as like if there's no repercussions for having a big pool party, people are going to have big pool parties. So having ticketing that like police or someone actually does send tickets out, somehow enforce it, if that kind of answers your question.
No, yeah, it does. Yeah, I guess just, I don't know if I'm allowed to do a follow-up, but just kind of, let's say, even if everyone listened, which obviously probably isn't going to happen, but even if, you enforced it and you had really good, following masks and all that, it seems like, or to me, which it seems like that wouldn't get rid of coronavirus. It would just slow the spread a lot, but still not to the point where it would die out.
Yeah, so two things. So one thing is that if these things had happened at the beginning, we have evidence that it would have, right? Because if you look at Taiwan's numbers, actually that's a good one to, I always go back and look at Taiwan's numbers just to cry to myself about the world that could have been. So for context, Taiwan's population is, let me see, 23.78 million versus California's population is like 39 million. So Taiwan has roughly a bit more than half the population of California. There we go. But their COVID cases are literally in the hundreds, and they only had 7 deaths total. So what are the reasons for this? I have a good paper. If you're interested, feel free to email me. I can send you a paper that I'd read. But basically, the moment there was anything happening in Wuhan, like the very moment in like late December that there was some note that, uh-oh, something's going on in China, Taiwan immediately shut down its borders and enforced the mandatory 14-day quarantine for anyone coming into the country. They enforced mandated like social distancing and mask wearing and all those things, and it worked. So I agree with you though that now that we're at the point that we're at in the US, I don't know if those measures would actually stop the virus. Like I think when it was just a tiny little ember, that would have flooded the ember and put it out. But now that it's like a forest fire, I genuinely have no idea. I hope it would help, but I don't know if it'll help anymore.
Okay.
Yeah, great questions.
Yeah, thanks.
I think Charlene has a question.
Hello. Hi. Can you hear me? Okay.
Yeah.
So again, regarding your opinion on the coronavirus and stuff, so South Bay has like one of the highest like coronavirus counts right now. How do you feel about that? And also, I'm a South Bay native myself.
Oh, nice.
So I often see that students from our area are underrepresented in STEM. So given your passion for accessible education, how would you suggest encouraging students from the area to pursue STEM?
Ooh, excellent questions on two parts. So first, where in South Bay are you from?
I'm from South San Diego, Otay Mesa area.
Oh yeah, I'm from Chula Vista. So yeah. I went to like Bonita Vista High School. I know Otay Mesa area very well though.
Yeah, I went to Montgomery.
Okay, nice. Yeah, I had some friends from Montgomery. So first of all, I think one thing that really bugs me about how people talk about the fact that COVID is like surging in South Bay is that they treat it as if, I don't like the way that it's verbalized in headlines or in emails being sent out by UCSD administration. Like it makes it feel as if it's like a separate entity. It's like, no, that's where I grew up. It's literally 30 minutes south of here, and both my parents still live there. I feel like people at UCSD are kind of treating it like the other, but it's like, no, it's literally in our bubble of San Diego County. And it doesn't account for the fact that, yeah, we have a much higher proportion of, like it's very like Hispanic dominant. And like we have a higher proportion of people that are being disproportionately impacted by COVID. So it needs especially a lot of effort down there. So it really frustrates me that I think San Diego didn't do as well of a job as they should have, because it's my hometown that's being disproportionately impacted by this. So that's my own gripe about it. But yeah, and then so as far as I am also very upset about it. The second part of your question of like the fact that South Bay is we have a large representation of people from demographics that are systemically underrepresented in STEM. I think the biggest thing is to push for outreach at the high school level, maybe at the middle school level if possible. I feel like if we can't get people interested in STEM by the time they're applying to colleges, we can try to capture that flame later on, but really they need to go to college for STEM. Like if you miss out on going to college for STEM, I feel like that throws you at a huge disadvantage. So I think making like research programs accessible to people in the South Bay. One big disparity that surprisingly I haven't heard any faculty at UCSD talk about is that, so for example, I went to Bonita Vista High School, we didn't have computers. We had one computer lab that was always reserved for like history classes doing research. And I think we had like 6 computers in our library. I think now that's changed, but I remember when I started UCSD, there was all these CS majors that had taken AP Comp Sci in high school. And like, even though I was relatively techie, because I just like technology, like it was a very clear disparity that like, why weren't the people from my high school ever able to learn basic computer science? So if you're also as passionate about kind of improving the ability of people from the South Bay to be participants in STEM and especially in higher education, definitely try to get involved with outreach. I've noticed that sometimes UCSD outreach programs end up being more like La Jolla, Del Mar centric, I think just because of proximity. Like if people don't have cars, maybe it's easier to commute to and from high schools in this area. But really, it's the South Bay that's, or I mean, in general, I mean, there's other parts as well, but like the area around UCSD is not that, like, they have a lot of funds. Like they're very well off schools. So I think making sure to push for that outreach effort to go more broadly than just the area immediately around UCSD, it's a great way to start. And if you're ever interested in like what groups are doing outreach, feel free to reach out to me and I can help put you in touch with people. Cool. Maybe Zichen, I think you're next on my list. I don't hear you.
Hello?
Oh, there we go. Yeah, I hear you now.
Oh, thank you. I just have a personal frustration regarding procrastination during this time.
Mm-hmm.
So I recently started doing an independent research project under Dr. Farhad I.
Mm-hmm.
So because it is bioinformatics, it is very remote, and and since this is my first independent research project, I'm kind of getting
Like a bad taste for it.
yeah, I'm kind of finding a hard time motivating myself since I'm just like the only person doing this thing. So I was wondering if you have any words of wisdom regarding like managing time in doing this independent research project.
Yeah, that's a great question. So I think, so in general, I think a lot of the faculty might not be the best at mentoring undergrads just because they're not really used to it. So part of it could be that he's maybe not as experienced with like, how do I create a research project for someone that has never done research before? So I think one thing that has worked for me when I am mentoring undergrads doing research projects is towards the beginning of the project, I like sitting down with the undergrad and like formally making a week by week timeline of like, what are the things we're going to do each week, at least for like a month or two in. And that timeline is most likely going to change very significantly as you start working on the project, as certain things you tried don't work. But at least having some vision in mind helps keep you on track. You know, having these week by week by week timelines helps you keep yourself motivated. Like, oh, I'm going to check this box off. I did this task. I'm ready for next week's meeting. Oh, that's another thing. I have weekly meetings with my students, and I always start with, you know, what did you accomplish last week out of the things we had discussed? And then we talk about what those results mean. And then we end the meeting with, okay, so for this upcoming week, these are the specific things you're going to try. So I would say maybe reach out to Dr. Farhat and maybe ask him, like, can we sit down and like plan a more organized, structured research project? Yeah, that's one thing that helps me. I also like keeping my stuff organized, so I use Trello to keep track of. It's like I don't know if you ever use Trello. I'll post the name in the chat. Yeah, thank you, Charlene. I just saw the chat. But yeah, so Trello, it's this online kind of pin board that you can use to keep track of to-do items that you have. And you can have different boards for different things that you're doing. So I have one for like my teaching, one for my research, one for my like household stuff. Like I got to fix the toilet, I got to whatever. And it helps me just keep track of stuff I do, and like checking stuff off really helps me keep track of stuff. I don't know if that helps at all.
Yeah, that's helpful. Thank you.
Awesome. Yeah, no problem. Thanks. Good luck. I hope it gets better. Maybe Ty?
Hi.
Hey, Ty, how you doing? Good to see you again.
Hey. I think like because I'm quarantined and stuff, it's like very easy to stay in my house and like play a bunch of games and not really like go out or exercise. So is there a way to like kind of maintain my mental and physical health? Because like I feel like this is gonna last for like the next like year, I think.
Yeah, I feel you. So I guess it depends what you have the resources for. So one thing is I still play Pokemon Go. I'm not as active because I only stay in my neighborhood. I don't want to spread out too far away from my neighborhood. But yeah, that usually helps keep me motivated. If you can I don't know what types of exercise you like doing, but like if you theoretically get a pull-up bar, if you're interested, you can look up like at-home exercises. For me, I like very, very much am not an exercise person, which is why I motivate myself with video games, because I love video games and I hate exercising. So like, I don't know, even playing like Wii Sports or like some video game that you could play that you like, but also gives you exercise, those might be good options as well. I don't know. That's just my own very weird perception of it. But yeah, mainly gamifying it has made it a little bit more easy for me to keep up with. So maybe it'll help with you. I don't know. Maybe Jose?
Hello.
Hey, how you doing?
Hey, Professor. Yeah, so in kind of like in addition to Charlene's question, I'm also a person from the South Bay, National City. And I was wondering how your first year at UCSD went, because my first year I felt a sort of not really cultural shock, but just a shock of meeting people from way different backgrounds that I would never expect to meet in person. I was wondering, as a person of the South Bay, what kind of shock did you experience coming into UCSD, if you had any?
Oh, for sure. Wait, first of all, yeah, what part of South Bay are you from?
National City.
Okay, nice, nice. Do you
Yeah.
know Highland Mobile?
Yes. Yeah.
Yeah, across from Seward. My mom used to own that, so I was always up on Highland like all the time.
Oh my gosh. I think it's
Like we
not
would
there
all go to
anymore, right?
Coconuts on the corner.
I see.
Oh man. So yeah. So people that are on the call might not be familiar. So South Bay is like very like there's a large Mexican American population. I think so. I went to Benita Vista High School. It was like I think 90% Hispanic background. Maybe not 90. Maybe it was like 80%. I can look up the numbers later. And then like probably like 10% to 20% white, and then like a handful of everyone else. I think I was the only Middle Eastern person in my entire high school. Maybe one of like 3 or something. So yeah, definitely kind of Jose, to your point, I remember when I started at UCSD, it was a pretty big culture shock because I wasn't expecting it to be that different because it's only 30 minutes away from where I grew up. But it was definitely a far different distribution of like ethnic backgrounds than I was expecting. So for me personally, I really enjoyed that because, you know, I didn't really know the difference between like Taiwanese food specifically versus like different regions of Chinese food versus like Hong Kongese food versus, you know, like it really helped me get a lot more, you know, like, I met a lot more people from backgrounds that I just had never met in high school. And it helped me like experience cuisines, cultures, and stuff like that. So it was definitely like a big part of my growing experience. I think that was the big positive side, just like learning people from a bunch of different cultures, learning about, you know, their experiences, things like that. But I do think that also comes with a little bit of a negative aspect I had. That was, you know, a public school is supposed to serve the people in that community. And I think one thing that I did see as a negative of the fact that it was such a different distribution of ethnic groups was that it doesn't really feel like UCSD is serving my community that I grew up in, which is the community in which UCSD exists. And I know San Diego itself is very diverse. So I know that like Northern San Diego has a completely different mix of people than like South Bay versus things like that. But even if you take San Diego County as a whole, it still doesn't quite match the distribution you should expect. So I think that kind of throughout my college experience, kind of following up on Charlene's question, it was one of the big motivating factors for me wanting to do more outreach. You know, when I was in high school, we didn't have people from UCSD talk and do workshops on like, how do I do bioinformatics? How do I do protein modeling? Things like that. So I remember when I was a senior, I organized a high school outreach event, and I had reached out to all of my high school professors down in South Bay, my high school teachers down in South Bay, to like see if they could make that workshop that I was running be extra credit for their students. And throughout the year, I had taken trips down to Chula Vista to like give small talks at the high school, things like that. So I think definitely it's good to kind of focus on the positive aspects of this big change, but also if you feel passionate about it, like use your position of privilege, because everyone here is at a university, which in itself is a privilege to be at. And use that power that you have as a university student to make the impact that you would want to see. It's definitely one of the things that I try to live my life by. And even now, I still try to do as much outreach as I can in South Bay. So yeah, I don't know if that kind of answers your question or is on the right track, but just keep up with it. Maybe Gordon?
Hi. So first of all, thanks for doing this
Yeah, thanks for being here.
Q&A. So it seems like today anti-science sentiment is really growing. So as someone with a background in both science and education, what are some ways that the scientific community could bridge the gap to digestible knowledge and help restore public trust in these subject matter experts?
That's a great question. Yeah, so that's been something that's been, I think, arguably one of the most frustrating things for me this pandemic has been like, so where I grew up, I mean, I was one of the few people in my friend group that went to college. And like a lot of my friends don't know science stuff just because they didn't get to pursue a higher education. But as a result, they're spewing a lot of nonsense sometimes. Like all these anti-vax things of like, oh, like a vaccination is really a microchip that the government's going to be tracking you from. Post it from my iPhone. Like, I think you're missing the microchip. Or like most recently, people were saying that like, why do they need to dig the sinus swab so deeply up your nose for the COVID test? Like they must be planting a tracker. And I genuinely had to argue with people that I went to high school with that like, no, it's not a tracker. They're already tracking you with all these other things. Like this is purely just to get a sample of the virus. And I think it's frustrating because you don't want to like lose your temper with people. You don't want to like be condescending, because if you're condescending, they're just going to shut down and be like, yeah, those academic like ivory castle assholes are, you know, like they don't understand the average Joe. So you have to kind of play this middle ground of like not being condescending, but still try to teach them what misconceptions they have, or like give them references to what they can learn. And I think the fact that science and knowledge has been kind of locked away in academia for so long. So for example, papers being behind paywalls that you can't access unless you're on UCSD campus, or like university content only locked away in the university. Those things make it even more difficult, because I tell people like, hey, you got to actually read the scientific stuff. Then they ask like, okay, where do I read it? And then it's like, oh crap, this is a paper behind a paywall. This is a course that's behind whatever access portal. So I think, I don't know how much this will impact you all as students, because this isn't really something that you can do as much, but one of the driving factors for me that kind of pushed me to go towards a faculty position is that I'm very, very passionate about making education accessible to everyone who wants it. And I think if a faculty member thinks that their job exists because like they have, like if they feel comfortable in their job because they have their materials, and that's the only value they add is sharing their materials with students, I think that's not the value that a faculty member should add. Like the value I add is students read my materials, and then we can interact about them, and I as an expert can kind of gauge where their misconception occurs. Something that a textbook or like a course will never be able to do automatically. So kind of my effort has been, how do I make massively scalable online courses that I can just share with everyone? So right now, Pavel Pesner and I, and UBIC people might know Sabeel Mansouri. He's a recent graduate who was in UBIC. We're working on this MOOC series specifically about COVID. So we're hoping to release that in a few weeks. But yeah, just I think faculty members got to do their part and like make education accessible for anyone that can reach it. Try to lower systemic barriers that prevent people from pursuing education. And I guess one thing that students could do is like, don't unfriend that like high school friend that's like spewing nonsense, or try to avoid unfriending them. I had to unfriend some people because I was just like getting too frustrated or too tired. But like, try to educate them in a non-condescending way. Try not to be confrontational. I think one thing that like really caught my eye as I've been in academia is that, like, as someone that grew up somewhere where not very many people are in academia, was that people in academia have no concept that people with differing views exist, or like they have no concept that people just have certain misconceptions about science. Like I remember my PhD friends had no concept that like they thought that people thinking vaccines were trackers was just like, you know, a meme or something like that. And like, no, I got a ton of friends from high school that have kids that I had to argue with that, like, no, vaccinate your child because, you know, you don't want your child to get polio or something. So yeah, I think you as undergrads might have even a better opportunity to like do really widespread outreach, like, you know, give talks at high schools, or, you know, I think there's a program called Skype a Scientist that I'm part of that I Skype with like K-12 schools, giving one lecture on some scientific topic. Volunteer at a high school like science outreach type thing. I know Alex is on the call. So Alex and I had volunteered at this thing that UBIC was doing at this science fair at Reuben Fleet Science Center down in Balboa Park. But yeah, I don't know. So yeah, just my 2 cents. Try to figure out how can you disseminate knowledge as easily as possible in like a non-condescending way.
Okay,
But yeah, my background's a Hobbit house. I can see that in the chat.
Well, I think that's the last question.
Yeah, go for it. Are there any other questions?
That's the last question.
Wait, no, I was a host, so I wasn't able to like raise my hand feature. So I have one more question in regards.
Yeah, Calvin, go for it. I think Michael has a follow up as well, so I'll go to Michael after. But yeah, Calvin, go for it.
Oh, okay, yeah, my bad. All right, so what do you think is the current state of the use of existing antivirals and repurposing them? And what do you think about like all the other treatments that are being developed right now, such as the use of monoclonal antibodies? And I know for like the use of monoclonal antibodies, they're like really expensive for like a personalized treatment. So how would you make that treatment more equitable?
Ooh, that's a great question, but one that I'm gonna admit I'm like not very well equipped to answer. So unfortunately, I'm primarily in the computational space, and I know buzzwords and like general principles behind how like monoclonal antibodies and like different therapeutics that are coming out. I have like some idea of kind of how they work, but I would by no means consider myself an expert. And honestly, if you've done any reading on it, you are probably more of an expert than I am. So yeah, I don't really want to say an answer because I don't really have one. I don't really know enough about it to give a well thought out answer. But that's an excellent question that you should definitely pursue. Rebecca, yeah, sorry, that's probably not the most satisfying response.
Yeah.
Michael, do you want to go again?
Yeah, I guess. Okay. Yeah, so this is a different question, more about kind of jobs. So my situation, which I think is pretty similar to a lot of people, is I'm doing the bioengineering bioinformatics undergrad, or the bachelor's, and then either the UCSD 4+1 masters, or another year to 2 year master's somewhere else. So kind of, and I'm not interested in a PhD just because I just really want to go to industry.
Yeah, I feel that.
Yeah, so I'm just, how do you think the job, obviously, a bioinformatics job, you could, not that you can get it easily, but you're qualified for it, theoretically. But other kind of jobs in more tangential industries, I know you talked about straight up a software job before, but let's say a job kind of aimed more at like a chemical engineering guy, or something more stats based, or something even like financial, just because you have so much CS. Do you think, how well prepared do you think you are for that kind of stuff?
Yeah, so I think as far as actual preparedness, I think you're very well prepared. I think it's still good to do a little bit of soul searching before you graduate to make sure you can take classes that kind of complement what you're trying to do. So like if you're trying to go into a more traditional software engineering role, maybe you'll add on CSE 110 as one of your electives or like courses in that realm. If you're trying to go into chemical engineering, maybe you'll take more classes in the bioengineering department or like more chemical engineering related courses. So I think as long as you kind of proactively choose electives, or keep in mind you can take classes outside of your major as well. So even if you've taken all your major requirements, but you just want to take an extra class on blank topic that might be helpful to you, I think there's plenty of opportunity to like be very, very well prepared. And I think what the major already encompasses would make you very well prepared with like minimal extra effort in computer science, like software engineering jobs, in bioinformatics related jobs, in biotech industry jobs, in chemical engineering jobs. I think at most you might want to like, honestly, maybe not even a class, like maybe even just research with the faculty that does something in that space just to get hands-on experience. Because I think one limitation with UCSD in general is that compared to like state schools, we don't place as much emphasis on hands-on stuff. We place a lot more emphasis on like theoretical learning. Whereas in industry, in addition to knowing the theory, they want you to be able to just kind of jump in and get work done. I think your major curriculum as is probably enough for any industry jobs that you're going to need in any of those fields. So maybe like something that'll get you hands-on experience. And kind of adding on to what Alex said in the chat, yeah, watch out for the bioengineering department's 4+1. I actually applied to it. I remember when I was an undergrad, paid the $100, and then they like pulled me in and said like, wait, but you listed computer science faculty on here. And I was like, yeah, I want to do bioinformatics research. And then they're like, well, this is really more for bioengineers, so you can't do it. So yeah, be careful. But I had another friend who was also bioengineering bioinformatics, but was working in a bioengineering professor's lab. And he did the 4+1 fine. So make sure that there's a faculty completely within the bioengineering department that does stuff you would want to do a 4+1. Does that kind of answer your question a little bit?
Yeah, that helped a lot. I do have unrelated another question, if I'm allowed to. I'm not sure.